Yeah, it means get the square root somewhere else. Why do we have to use a conjugate on this one? Because there's two terms, okay? So then what is the conjugate?
Square root of 5 minus square root of 3.
Why do we have to write it on the top and the bottom?
It has to be multiplied by 1.
It has to be a version of 1. Okay, good. So, and those are supposed to be 5s. So again, why are we foiling here? Well, you got to recognize that as the two quantities multiplied together, and then that just automatically means that you're foiling. All right, so then we're taking this radical 5 to both of these, and what do we get? What happened? Why is it 5? Why is that first one 5? Because it's the square root of 5. So remember, when you're multiplying radicals, you multiply the outside numbers. In this case, it's 1. And then the inside numbers, so 5 and 5. So like you said, the square root of 5 squared. So can I just write that as 5? Okay. And then radical 5 times negative radical 3. What if it was like that? Is that okay? And then now we're on to the radical 3. We're going to distribute that. So plus,
Positive 15.
and then
Negative 9.
minus 3 if you simplify it because it's the square root of 9, right?
Yeah.
Okay.
And then the 15 cancel out.
So yeah, the whole point of the conjugate is these two are gone now.
So it would just be 5 minus 3.
Yeah, hold on. What about, hold on.
Oh, yeah. You gotta do the bottom too.
Okay, and so, we're going to multiply this denominator, but that is, you don't need to distribute that because maybe we got to simplify it later, so no need to do double work. And so then now we're just doing 5 minus 3. And then there's nothing to simplify from there. Is that okay? All right, so then we'll do part B. Can I move this down? All right, so what's the conjugate? Right, all you're doing is changing that. Got to do it top and bottom because it's a version of 1. Foiling the top. So what happens when we foil the top?
7. It'll be 7.
7 because it's the square root of 49.
And then
Square root of 21. That wouldn't be.
Because that's an outside number and an inside number. Say it again.
3 to the square root is
3 square, yeah, so plus 3 square root of 7.
and then minus 9.
Well, let's finish it off, right? So then, right, we got to do this still.
Oh, yeah. Negative 3 square root of 7.
Right, and that's why it cancels.
Okay, I can't get this now.
Now minus 9.
Underneath is 4 parentheses. Square root of 7 plus 3.
So again, the 3 radical 7 minus 3 radical 7 go away. That was the whole idea. That's why we picked what we did.
That was 7 minus 9
And now, of course, and this is why it's nice to write it like 4 parentheses, because now, right, we're just going to treat that like a fraction. So divide them both by negative 2. Or, just 2, I guess. So then it would be, I'll do it right here.
1 over 2.
Yeah, so negative 1 over 2 square root of 7 plus 3.
Did you multiply or distribute like 1 before you did that?
So you could, so here's the thing, like if you did that, then when you simplify by 2, then you just have to divide
By 12?
the 12 by 2 also. So just, if you write it like this, then I think it's less work, but it doesn't make any difference. All right, so how's that? What about anything else from either that section or what you guys did yesterday?
81B.
Oh yeah, man. So the other class didn't think they. Oh wow. Okay. Yeah, we should definitely do 81B for sure. Yeah. That is a good one. 81B. Okay. What do you think? What are you gonna do?
Multiply the indexes, right?
Yeah, so I'm gonna, yes, so you're correct, but I'm not gonna do it that way so that we can look at them as exponents. And that's why you get to multiply the indexes, because they are actually exponents. So how about we look at just the inside right now? And so would it be okay if I rewrote this one as,
Yeah.
is that okay? Does that make sense? And so then, does it make sense that I can do that now? Is that okay? And there's different ways that you could do it. I mean, you could say, if you wanted to, and maybe this is better, I don't know. But so you could do, you could do something crazy like this if you wanted. If you don't like this, stop listening real quick. You could do something crazy like that. Yeah. Okay, so stop listening. Ignore that one. If you're okay with the way I did it first, then just think of it that way.
That would just make that, like 1/8.
Yeah, right, because now we're doing a power to a power, so then, multiply. And so then, and this, what Donnie said was like much more quick, but that's why you're actually multiplying the indexes, okay? So, I imagine they wanted it like this. Okay, is that okay? Yeah, exponent rules, a lot of fun, man. Anything else? Ouch.
Can we do 59 on
that's fine.
37? Page 37.
All right, if there's another one from that other section, we'll do that one if you'd like. What number? 59?
Yeah.
I just wanted to do one of the workarounds.
Sure. Deal. Okay, a closed box is constructed by cutting along the solid lines and folding along the broken lines. Okay. Cutting along the solid lines and folding around the okay, fine. Rectangular piece of metal shown in the figure. The length and the width of the rectangle are 45 and 15. Find the volume in terms of x. All right, let me draw. So the dotted lines are
What you fold?
the dotted lines are what you fold, right?
Yeah.
Yeah. Okay. So then, what if I drew the box like this? Oops, should be right there. So if I drew the box like this, what are some of these dimensions? So I'm looking at what is this dimension?
3.
What do you mean by that?
Well, so you got to kind of fold this thing up. Let me draw this. Let me see if I can draw this other one.
You're talking about like front and center or something like that?
Yeah, well, we got to figure out how these get lined up. So then this is a dotted, and that's an X right there. And then it's solid, and then dotted, and then dotted again, and then dotted. And I'm missing something here. So this is solid. Yeah, this is obnoxious. So that's an X, and then this is dotted. Yeah, I'm not drawing this very good. Yeah, this one's kind of obnoxious, isn't it? So, the way I'm looking at it is this, and tell me if I'm wrong here. it looks like to me that this is like this part, this little X. Does that look right?
Yeah, should, what? No,
No?
Should be.
no, it'll be the,
Because I didn't fill everything else out.
it's
So
gonna be the dotted X on the left side. No? Can't be that either.
hold on. Yeah, this is kind of obnoxious the way they got this written.
Yeah, that's why I picked this one.
Yeah, so, okay, so then we got an X here and an X here. So how about this? What is, and this is dotted,
It's either the top or the bottom.
what is, so right, are we all agreeing that the dotted is like what the dimensions of the box are? Can we say that? So then, how tall is this box then?
15 centimeters.
Well, no, this is 15 over here, right? And so then we fold some stuff around. And then was it 45?
It'll be something like 10, 8.
Well, okay, so
35%.
so like let's use X when we're doing it. That looks awful, but yeah, I tried to draw it on this thing. It doesn't work very well. So how about this? How many? So let's look at the 45 side. Probably in the book is better. But if we're looking at the 45 side, how many X's are we going to take away from the 45 to get that dimension?
3.
Looks like 3 to me, right? Because those are all the solid lines.
Yeah. The 2 on the left side, the 1 on the right.
And then if we're looking at, so that's one of our dimensions. What about the 15 side? What are we getting away from the 15?
1. No. Yeah, 1. 1 X, right?
Well, I mean, it looks like it's 2x to me because those are the 2 solid lines, one on top, one on bottom.
But does that change anything? Because it's straight across there. So it's gonna, one is gonna be the same as the other. You know what I'm saying?
Well, right, so like we have this piece, then we're going to fold this up and we're going to fold that up. So if this was 15 here, we fold that x up and that x up. So should it be 15 minus 2x though?
Yeah, I get you.
Is that?
Maybe, yeah.
Because, right, like, I know my drawing's not very good, but like this dotted here and this dotted here, right? So like we're folding this part up and then this part up?
Yeah, but there's no X on that bottom.
Yeah.
Right, but since we're going to assume that these lines are perpendicular, then we can say that it's still x. I mean, yes, you're right, they don't say that. But to me, it looks like they're folding it up the same. So yeah, I'm gonna go with 2x right now. Because it's still getting folded. And so then, what's our third dimension then? And I'm kind of looking at, like, in between here is going to be, like, this part.
Yeah.
Like, right, like here. And so what is that width?
Just 1X.
Yeah, I think it's just 1x. And so this would be, like, the dimensions of it. At least that's what I'm thinking right now.
45 minus 1X, wouldn't it? Or not?
No. 3, 5, and 7.
Well, and so then, like, I think part of what they're asking is to FOIL this out. Because what are they saying? Close box. So, right, like, the way I'm looking at it, and maybe I'm wrong, could be wrong here. So I'm saying that the volume would be x times 15 minus 2x times 45 minus 3x.
Times X.
Yeah, I got the x out front. What do they got in the back? Is that what they have that in the back, or they FOIL it all out?
What page is the instrument? 70? 74, I think. Let's find it out, because 7 forms it. What number?
59, yeah.
V equals,
Yeah, V equals X.
remember they have 45, subtract 3x over
3x over 2.
2. Yeah.
45 minus
3x over 2.
2.
Do they have 15 minus 2x?
Yeah, they have an x.
45 minus 3, basically 3 halves x?
Yeah.
Basically, just put that 45x.
Over 2.
This whole thing is over 2.
Yeah.
Like all of this is over 2 like that?
Yeah.
That's entirely over 2.
But the whole thing's in parentheses, like the parentheses go down.
So it's saying it multiplies.
Why would that be divided by 2?
I might be trying to take the top side and the bottom side.
Yeah, I guess,
That makes no sense. 15 centimeters supposed to be doing the same.
well, I think what's going on, my picture that I drew is kind of bad. So like, because they're saying like this area to me, like would be the base. And then if you're looking at the picture, that would be the height, or I'm sorry, the top of the box. So like the bottom of the box and then the top of the box. Mine's not, like, their dimensions are a little more accurate. So, okay, so here's I think what's going on here. Does it make sense, like if you're looking at the picture, does it make, so it's 45 all the way across, right? And then does it make sense that we're taking away that x, and then that x?
So you have to cut those out.
Yeah.
Yeah, so you cut those out, so that would be the 45 minus 3x. And then they're saying, well, you got to split these two parts equally. And that's where the dividing by 2 comes.
Oh, okay. So it's
Okay.
It's talking about the lines you would fold instead of the lines we would cut.
The part on the left side of that, you can see in the drawing of the folded box, it's like a lip.
Yeah, right, so,
All
yeah.
the way in, so then it's closing over top.
And so I think the key is that, again, my picture's not scaled right, but this one and this one are really the same size. And that's why you're splitting it in half, what's left over.
That makes sense.
Okay. Yep, that's a tough one. I actually worked in Frito-Lay for a while. Was that where all these were? No. Where was I working at? Did this. But you can get boxes designed for like anything, and then they come in like a pallet, and it's just a bunch of flat cardboard, and they have all these like little dots. It's kind of like if you ever anyone that works at a pizza shop, like you know, you got to make the boxes. Like they can make them all kinds of different ways, and so then you have to fold them. So, anything else?
53.
Same page.
Yeah.
Must the sum of 2 second-degree polynomials be a second-degree polynomial?
Skip this one.
You skipped it. This is a good one. What's second degree mean? Ah. Is that what is it? Yeah, that's what, so degree referring to the exponent. Degree of the polynomial is the biggest exponent is whatever they're saying the degree is. So you could have like, one of them could be, well, I'll use up. So like one of them could just be like that, and another one could be like that. So then what they're saying is if you add them, is the degree going to stay the same?
No.
If you add those two problems? Yeah. You're not multiplying it, you're just adding it.
Yeah, so the only way you're going to mess with exponents, right, is if you're multiplying or dividing, right?
Yeah.
So if you're just adding things together, right, yeah, the exponents aren't going to change, so the degree is not going to change.
Yeah.
Okay. So then,
That'd be
sum,
like,
not
it'd be
the-
2f
Yeah.
squared plus 3x
yeah, that's supposed to be enough, but yeah, right, yeah.
minus 6.
Is that okay?
Yeah.
That's supposed to be enough.
That makes all kind of sense.
So, right, so then there's no way, if they're both second degree, that you can get anything besides the second degree. Well, I guess, wait a minute.
What about if it's in parentheses?
Okay, so, this is kind of dirty, but what if I did this?
No, you can't do it because it would cancel out.
Well, okay, so, but are they two polynomials of second degree?
Yeah.
And when we add them, is it still going to be a second degree?
No.
No.
So then I guess there's your answer, right? So then it's not always going to be true. Here's an example where it would be false. Is that okay?
When you said that it was gonna be dirty, that wasn't as hard as I figured.
No, yeah, but like, well, so they say the sum, and if they, you know, that's why I didn't think about like subtracting them, so. All right, how we feeling? Is this okay? We're gonna have a quiz. It's up there. We're gonna have it on Wednesday. Well, it was gonna be tomorrow, but then we didn't get far enough in factoring because we got to factor today. It turns out people forget about factoring.
I have a feeling this year might be the year that I have to be taking.
Why would you do that? Why don't you just
I don't understand. I really
don't understand why?
It's like the first time I actually had to study for a math quiz.
Well, you might have to. Yeah, I mean, this is big. We're gonna be doing big time stuff. Yeah. No, you guys are doing fine. We're gonna start factoring. Turns out we can't get everything. We didn't get all the way through everything because we wanted to do enough examples. So tomorrow we're gonna do the map test because we gotta get this thing taken care of. Get that out of the way. Tuesday we're going to finish the map test if we have to, / finish the factoring.
Okay, yeah.
Avoid a Monday.
We're off on Monday.
We're off on Monday.
Labor Day.
Labor Day. And then we're going to take the quiz on Wednesday then.
Okay.
Okay? Everything over that we've done so far is free game. But I'm going to tell you, you're totally going to have, like what we started off on, whoever picks 77, you're totally going to get one of those. No question. You're totally going to get a bunch of factoring. So let's make sure we remember how to
What
factor.
about questions like 59? We get any of those?
No, we won't have any of those.
Thank God.
There's some word problems, but it's not like that. That's a tough one.
That's amazing.
All right. So, how many people remember anything about factoring?
If you write down everything, I
If you do one problem, just so I can.
That's it?
with the
I
fact-
just have to do one.
I think
This is
you
super
did
awesome.
one so I could see
Oh,
it.
factoring.
Are you talking about like the
I can
distributing
connect what-
C and it should add up to B? You're talking about that? Yeah, I remember that.
All right, good. All right. All right, so let's get on page 38. We're on page 38.
I need one problem.
38.
Oh, it says, never mind.
You need to be able to factor like this. Boom, done, factor. Right? So, those of you that I had last year, which isn't a huge amount of people in here, I had a list over here that was like, here's all the steps of factoring. Okay? And then I did A times C, and that's up over here for you. But the very first thing that you should always do when you're factoring is look for the greatest common factor. So this first section, and so you should always do that, always. So this first one is just a greatest common factor problem. Is it okay that it's 5?
Yes.
All right, so then we factor out a 5
Y minus 6.
and y minus 6. Is that okay with everyone?
Great. I think I got it.
You got that one?
No, I'm serious.
All right.
Oh, wait.
Well, hold on. Well, that's,
Just
all right.
kidding.
That's greatest common factor.
I should never get confident. Unless
You guys have it's a lot of, what's the right word?
confidence.
Issues. Yeah, you got a lot of confidence there.
Oh.
38. Difference of squares. Do we remember difference of squares?
What?
We're doing 70.
Yeah, we can do a bunch of these. They only take a couple seconds. So if you guys that I had last year, the next step after greatest common factor, because you should always do that first, was count up the terms, and then that determined like what you would do. So 2 terms. So once you get to 2 terms, you should either be checking difference of squares, which is this one, or the sum or difference of cubes. Okay, so I don't remember how much of the cubes we did. I know we did a little bit, but okay, we might not.
I'm not gonna lie, I have no idea what a term is.
Oh, okay. What's the term? Yeah, that's important.
I don't know, yeah, I don't know the difference of squares.
I didn't learn it last year. Like I don't remember it from last year. So.
It's just like X squared, that's
That's a term.
I had
one
to
fourth
turn.
of the term.
Yeah, so they're broken up by pluses and minuses.
Oh, okay.
Yeah, okay. All right, so 2 terms, subtraction sign, difference. Are these perfect squares? Like, can you take the square root of both of them?
No, only one. Well, yeah, you
Yeah,
Yeah.
Yeah, what did it be? 160?
it'd be.
Not square,
just
square root.
X and.
160.
No, I don't want you to square it. I want you to square root.
Oh, and the square root of 1.
1 over 2.
1 over 2, there you go. So, right, you take the square root of the first term, get an x. Square root of the second term, 1/2. right? Because what's the square root of 4? 2, so that's why, okay.
This is the plus and minus.
This is the plus and minus one, yeah, so then you're done.
Yeah,
Okay.
that's what I remember doing these.
I think I did this like freshman.
No, we.
Yeah, you should have done it, you should have done this freshman year, correct.
So that's only, there's some.
This is
subtraction
exactly
sign
what we did
do.
yesterday.
All right, listen, very important. Difference of squares only works 2 terms, subtraction sign, and you can take the square root.
Just, cube roots where you have to do 3 of them. And
Cube root is gonna be, you gotta know the formula. So we're saving that one for Tuesday.
Isn't
I don't think we'll get to it.
Isn't it because 70 worst is because the 1/2, they both have an x and it'll be 1/2 x and minus another 1/2.
Kinda just like the conjugate, yeah, right, because then those cancel out, and that's why you only have 2 terms, yeah,
We
right.
basically just did this yesterday, except the opposite way.
Kind of, yeah.
Alright, now we're back into it a little bit.
All right, yeah, that's why we gotta do this review to get you guys right and back. Okay. 2 terms, subtraction sign. Can you take the square root of both of these?
Yeah.
All right, so it's difference of squares.
It'll be 3y and then minus 7, 3y plus 7.
Well, you gotta watch your signs though.
3y.
So I would just do the way they got it written.
Okay.
Unless you wanna take out a -1, and then you
Can we,
can look at
can we
that.
just move, can we do 3y minus plus 7?
Can't do
3y plus
considered property for a minus 7.
Well, and what you guys are trying to do is if you did this first.
Yeah, I would do that.
And you can do that first, that's fine, and then your answer would be,
Oh, that's just too much work.
that doesn't seem like a lot of work.
It's just extra.
You do one thing.
Yeah, there's no need to do that.
But you gotta have that negative sign in there. You can't just say it's 3x plus 7 and 3x minus 7. All right, let's do another one of these.
Not that bad to it.
They're not that bad. at least
No,
I
these
don't-
are not. These are not bad.
See them bad. What? D squared plus 10z plus 25.
Is this considered to be 3 terms?
No, so that's the key. Now this is really, right, this is the first term, and then this is the second term, this whole thing. And so it is 25 square root, and you can take a square root of this as a whole thing, yeah.
Okay.
So then,
Well, wouldn't the square root of that just be z plus 5?
correct,
Yeah. So it'd be 5z plus 5?
5 and 5, z plus 5, z plus 5, if I can get it in there.
Then the subtraction one. Oh, that's.
Same process, it doesn't matter what it is. If you can identify it as 2 terms, subtraction sign, square root. Same thing every time. Now in the back of the book, they're gonna have this simplified down a little bit more. Okay, but,
For that, you just have to boil it, right?
well, you just so what they're gonna have in the back of the book is z plus 10
That's what I say, 'cause you add.
and negative z. That's what they're gonna have in the back.
Yeah, that's not confusing about. Technically, you could add that.
All right, so is that okay?
Yeah.
2 terms. 3 terms. Yeah, that's just over here, but, right, in case you need to see it again, those are basically the steps for the A times C method. So if there are 3 terms, of course you're looking for the greatest common factor. Always look for the greatest common factor. Okay, and then you're going to go through these steps. Does everyone know what descending order is?
Yeah, so like x squared x.
Yeah, nothing. Is that okay?
Yeah.
Always in descending order.
This is always ABC and we factor.
Say it again.
ABC, the A times C, and then have to add the B.
Yeah, correct. Yeah, and that's what all this says, right? I didn't put it on here, so right,
What do you want?
right. So then it's ax squared plus bx plus c.
Yeah.
That's what all this is referring to. How are we doing on time? What do we got?
If like 10 minutes.
10 minutes. Okay, so we'll get as far as we can here. I'm going to do all those steps that I just showed you. Okay, but A being 1, I wouldn't do, you guys shouldn't do all these steps when A is 1. I'm going to do them all right now. What is A, B, and C?
1, 5, and 6.
Okay, and please watch your signs. So then off to the side, you're going to do 1 times 6, and that gives you 6. So then factors of 6 are 1 and 6, what else?
3, 2.
All right? One of these sets adds to give you B,
3 and 7.
3 and 2. So those are the ones we're looking for.
Yeah, you do.
So then you're, well, okay, so this is the way I do. So then we rewrite it, x squared, excuse me.
Plus 2 is plus 3x plus 6.
Then
And
you
factor
factor
out.
down.
Okay, so now I'm going to stop real quick, and then everyone look at 93 and 95. When you have 4 terms, group the first two. Okay, so right, because when we did it before, when we did it last year, we did 4 terms after 2 terms. Okay, so then whenever you have 4 terms, the very first thing you should do is try to group them, the first 2 and then the last 2, and see if you can take out a greatest common factor. So what's the greatest common factor of the first 2?
X.
And you're left with,
X plus 2.
and what's the greatest common factor of the next 2?
3.
All right, so then take the that sign there plus 3, and then,
X plus 2.
and so then that factors into,
X plus 3, or no, yeah.
yep, x plus 3 and x plus 2.
Or
Is that okay? All right, now here's why, for your all's level, you shouldn't be going through that when A is 1, because these 2 numbers are just what ends up down here, right?
Yeah.
Okay, so when A is 1, I mean, you're welcome to do this until you feel comfortable. Okay, but when you're doing A is 1, these factors that are factors of the last term, that add up to the middle term, boom, you're done. Okay? Let's jump down to 86 then.
Will this be T?
Well, I was going to do 86. Do you want to do 82?
Yeah, just did that real quick.
Yeah, okay, so can we do, we'll look at 82 real quickly.
It's T minus 3 and T plus 2. T minus 3 and T plus 2.
Yeah.
So, right, factors of -6 that add to give you -1.
Negative 3, positive 2.
Right? So you don't have to go through all that. That's what it would be. If you FOIL that out, that would be what it would be. Now, I'm going to tell you that most of the time, when I still feel like I got to do like your answer key and stuff for your quizzes and stuff, when I factor when A is not 1, I almost always do all these steps. Okay? So I would do those steps. Now, like maybe I wouldn't on number 86, but that's okay. That's different. Let's not worry about that. But let's go through it this time. What is A, B, and C?
2, 1, and
2, negative 1,
Um,
negative 1.
Please watch your negative signs. 2, -1, -1. Is that okay with everyone?
Yeah.
Okay, so then 2 times -1 is...
Negative 2.
Now, just to be clear, it could also be this, right?
Yeah.
So you got to pick the right one, and they have to add to give you -1. So which is the...
Negative 2, positive
Oh, wait a minute. Sorry. I just rewrote the same thing. There we go. It could be that, right? That's what I meant. It could also be that.
Negative 2, positive 1.
And so then we have to do -2 and +1. So then it's 2x squared minus 2x plus 1x. It doesn't matter which order you write it in. We got 4 terms now, so what comes out of these first 2? What's left over?
X minus 2.
X minus 1.
And find out.
What comes out of the next 2?
1.
1, right? Yeah. If you wanted to say nothing, that's true. But when you're factoring, nothing means 1. Okay, so 1.
X minus 1.
Figure 2x.
No, positive 2x.
So what does it factor into?
2x plus 1 and then x minus 1.
You do 88?
Sure.
Might as well, right?
Do you have to factor in -1?
No, I usually do, but no, you don't. Okay, so this is another one of those ones that you decide, and so this, if you guys didn't hear what he said, Let me write it down first. He asked, do you have to factor out a -1? And the answer is no, you do not. Okay, you can treat your A as -5, your B as -13, and your C as +6. Do you want to factor out a -1 first? I don't care. You're doing a slow nod. Either you're like totally hip and cool, or you're saying, yeah, it doesn't really change anything. What would you guys like to do?
I'm just doing it regularly.
I don't care. What do you guys want to do?
Just do it.
Just do it. All right. So A times C is what?
-30.
All right. So now you got to list out all. No, you don't have to list out all the factors of -30. You just got to find the ones that add to give you -13. -5 and -6.
Wait, no, never mind.
That doesn't work. Why does that not work?
-15 times.
I did something wrong with it.
So this one's kind of a tricky one, right? Because like all kinds of different ones almost add up to 13, right?
No, you didn't do it this time.
So 3 and 10, but that one doesn't work. Someone already said what it was.
It said -15 and 2.
-15 and 2. Why is that the one we want?
Because that is -13.
2 plus -15 is -13.
Because A gives you -30, and B it gives you -13 when you add them. All right, so then -5u squared minus 15u plus 2u plus 6. Again, don't worry about the order because it'll always work out if you, as long as you're doing it all right. What comes out of that first one?
-5u,
What's left over?
u plus 3.
Is that right?
Take the 2 and just u plus 3. So that'd be -5u plus 2. U plus 3.
Now you could totally do these and get your signs a little bit different than this. Because like for instance, if I wrote plus 2u minus 15u, the signs might be in different places. Okay, but as long as it, just follow the pattern and then you'll be fine.
Does the order of the answer matter?
No.
In terms of where the brackets are? Okay.
No. No, don't worry about that. Okay, so, are we okay on 94 and 96?
Yeah.
Yeah.
Okay, group them.
Spaces don't matter.
Yeah, so here's the problems I want you to work on. Tomorrow we won't have time to answer any questions. Okay, so I won't even look at so if you want to save this to do over Labor Day, I mean, that's your deal, I guess. Because I'll look at these on Tuesday when we get back. Because when you get in here tomorrow, grab yourself a Chromebook. Let's get that map test taken care of. Tuesday, you'll either be done tomorrow on the map test or you'll have time to finish on Tuesday, and then I'll stop you, and we'll hit the rest of this factoring so that we can be ready for the test on Wednesday.
Wednesday, we just walk in and just like taking the test.
Yeah, Wednesday you're gonna walk in, I'm gonna give you the test, yeah. Okay? Is that all right?
Yep.
All right.